Hello again. Today we are finding greatest common factors. All right, so let's get started. Let's say I have 15x and 25. What is the greatest common factor? What's the biggest thing that I can divide them both by? Well, I can divide 15 and 25 both by 5. Notice that 15x has an x in it, but there's no x here. So can't factor out any x's. So the only thing that we can factor out is 5. So the greatest common factor of these two expressions is 5. Another way to look at this is we could factor the 15 and then bring down the x. So I have 3 times 5 times x. And I'll factor the 25 into 5 times 5. Well, what is in both of them? The only thing that I can take out of both of them is the 5. So that's a way you can look at factorization to find the greatest common factor. So here I have 24x to the third and 16x. All right, so I want to know how I can factor this to find the greatest common factor. Well, I can factor 24, and I also see that I have x to the third, so that's going to be x times x times x. So 24, I can factor that into 4 times 6. Well, I can factor 4 and 6 as well. So 4 is 2 times 2, and 6 is 2 times 3. All right, I can bring down my x's. All right, so I have 2 times 2 times 2 times 3 times x times x times x. Now, if I do a prime factorization of 16x, that's going to be, let's say that's 2 times 8, and I'll bring down the x. So times x, and there's only one x. So now I have 2, and I can bring that down. And then 8 can get factored into 2 times 4, and I'll bring down the x, times x. Now 4 can get factored. So I'll bring down the 2, bring down the 2, and then I have 2 times 2 times 2 times 2, and I bring down the x, so times x. All right, so my prime factorization of 24x to the third is 2 times 2 times 2 times 3 times x times x times x. And my prime factorization of 16x is 2 times 2 times 2 times 2 times x. Now here's the question. What is in both of them? Well, I have a 2 here and a 2 here. I have a 2 here and a 2 here, 2 here and a 2 here. All right. The 3 doesn't have anything to balance it. This 2 has nothing to balance it. And I have 1x here and 1x here. So 2 times 2 times 2 is 8. And bring down the x because there's an x. 2 times 2 times 2 is 8. And there's an x, so it's 8x. So my greatest common factor is 8x. Another way to look at this is, what's the biggest number I can factor out of 24 and 16? Well, the biggest number that's a factor of both 24 and 16 is 8. And there is a variable of x, so I can factor out an x. And what is the smallest exponent of x? And you'll notice that there's no exponent here, so this is x to the first. All right, so these are both x to the first. But when it's x to the first, you don't have to label it x to the first. So that's a simpler way to find the greatest common factor of those two expressions. So here I have 3x squared and 9x squared minus 6x. And I need to find the greatest common factor. Well, let's look here at my binomial. And what can I factor out of both of those terms? Well, 9 and 6, I'm going to see right away I can divide them both by 3. And I can divide them both also by the lowest power of x. Well, Here I see that I have x to the first power. So when I divide both of those, I'm left with 3x times 3x minus 2. And I'll bring down the 3x squared. So what can I divide both of these by? Well, right away I see I have a 3 and a 3 and an x and an x. And so I can factor both of them by 3x. So that means that my greatest common factor is 3x. So here I have x squared minus 16 and x squared plus 8x plus 16. And I need to find the greatest common factors. All right, so if I'm going to factor x squared minus 16, right away I see that that is a difference of two squares. So I'm going to make two parentheses. And a difference of two squares has a plus and a minus. So now I'm going to take the square root of both terms, and the square root of x squared is x, and the square root of 16 is 4. And that's how you factor a difference of squares. Over here I have a trinomial, so I'm going to try to factor it. So what two numbers multiply to 16 but add to be positive 8? Do you know two numbers that multiply to be positive 16 but add together to be positive 8? Well, I'll make some parentheses here, and I see that I have an x squared to start. So I will put an x in each of those parentheses. Both of my signs are plus signs, so I can make both of these plus signs. So what two numbers multiply together to be 16 but add together to be 8? I would say that they are 4 and 4. Now, do you see something that both of these expressions have in common? They both have an x plus 4. So my greatest common factor is x plus 4. So here I have x squared minus 1 and x squared minus 2x plus 1. All right, and I'm looking for the greatest common factor. So I see right away that x squared minus 1 is a difference of squares because I know the square root of x squared and I know the square root of 1. So I'm going to make two parentheses, and I know that one has a plus sign and one has a minus sign. So I'll take the square root of x squared, which is x, and I'll take the square root of 1, which is 1. All right. Now I see here I have a trinomial, and I'm going to try to factor this trinomial by finding two numbers that multiply to be positive 1, but add together to be negative 2. Well, if two numbers are going to add together to be negative, but multiply to be positive, they must both be negative. All right. And now, what two numbers multiply together to be 1? Well, the only numbers I know are 1 and 1. And I see here I have an x squared, so I can factor that into x and x. So now, do you see a common factor for both of these expressions? I see that they both have x minus 1. So my greatest common factor of these two expressions is x minus 1. And that's the greatest common factor.